Good afternoon, Algebra class. Today we're going to cover the last section in Chapter 4, which is Section 4.7. And this is talking about sequences and how we can write functions to represent them. A sequence is just an ordered list of numbers that often form a pattern. So each number in the list is called a term. So we're going to refer to terms that generate a sequence. Here's an example. You may have heard or seen this one before. The Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13, and 21. Well, the Fibonacci sequence is a sequence of numbers where the first number is 0, the second number is 1, and each one after that is made up of the sum of the previous two. So if we add 0 and 1, we get 1. To get the next sequence, we would add the 1 and the 1 to get 2. Then we're going to add the 1 and the 2 to get 3. So you're always adding the previous 2 to get the next term. From the Latin word sequentia, if I pronounce that properly, which means to follow, is where the word sequence comes from. So here's an example of a pattern or a sequence: 5, 11, 17, and 23. And we want to determine what are the next two terms of the sequence. So we should first figure out if there's a pattern here. And we can see that we're taking 5 and we're adding 6 to get 11. And then we're taking 11 and adding 6 to get 17. And then we add 6 again to get to 23. So it appears that we're adding 6 each time. So 23 plus 6 will be 29, and then 29 plus 6 will be 35. So we've identified the pattern, and then we just continued it. Now we're going to talk specifically about an arithmetic sequence. An arithmetic sequence is something that has a common difference for its pattern. So the pattern is created by adding or subtracting. I'm going to fix that right there. So once we've determined the pattern, it is adding the same thing each time. So we want to determine if this sequence here fits into that pattern. So to get 15, we would have to add 7 to 8 to get 15. And then we're going to see if that continues. So if we add 7 to 15, we get 22. So it works there. But then we get to the last one, and when we add 7 to 22, we do not get 30. So we would actually have to add 8 to get to 30. So this is not arithmetic because you're not adding the same thing each time. So here's another example. We're going to add 2 to get 9, add 2 to get 11, and add 2 to get 13. So this is an arithmetic sequence, and the common difference for this sequence is plus 2. Let's talk about writing a formula for an arithmetic sequence. A recursive formula is just developing the pattern and then continue that out to get to a further term. So in this case, we want to try to get to the 9th term. So we would say we're going to take the first term, which we identified as 3. So the first term plus what? So we got to identify what are we adding each time. It looks like we're adding 6 each time. So our common difference is 6. Positive 6 to be exact. So we're going to add 6 to our first term. So 3 plus 6 is 9. Now to get the third term, we're going to take the second term, which we identified to be 9, and again add 6. So 9 plus 6 is going to be 15. The fourth term would be taking the third term, which we just found, and adding 6. So 15 plus 6. So the recursive formula for this is to take the previous term plus 6. So we're identifying the previous, that's a V there, previous, as the a sub n. So if we wanted to find a sub n, we'd have to use the n minus 1 term to get that. So we're going to continue this pattern out, adding 6 to the fourth term. So 21 plus 6 will be 27. And then we're going to try to find the next term. So I'm just going to fill these in. We know we're adding 6 each time, but it's always taking the previous and adding 6. So we get 33. And then we're going to take 33 plus 6, which is 39. And then 39 plus 6, which is 45. And then 45 plus 6, which is going to be 51. So 51 will be the 9th term in our sequence. So this is called a recursive formula. It is just developing the pattern and continuing the pattern out. That would be quite tedious. Let's say, for example, we wanted to find the 100th term. That means that we'd have to continue this out until we got to the 99th term so that we could actually add the 99th term plus 6 to get the 100th term. So there's got to be another way of developing this pattern without having to continue it. Well, this is called a rule for an arithmetic sequence. The rule for the arithmetic sequence, and we're going to remind you that this is just function notation. A of n just means function. And in order to find the nth term of an arithmetic sequence, we're going to take the first term. This is identified as the first term. And we're going to add the term number that we're trying to find. So if this was the 100th, we would then subtract 1 and then multiply by the common difference. I want to go back to the previous screen. If you notice, each time we added 6, we were able to get to the 9th term. We'll count out how many times we added 6. We have 3 here, 4, 5, 6, 7, 8 times that we added 6 to get the 9th term. So we're always going to add the common difference one less time. So that's where they got this formula of n minus 1. So if we had to write an arithmetic sequence for the sequence that we just did, we would have to identify the first term, which if you remember, that was 3, plus n minus 1 times 6. 6 was our common difference, is what we were adding. So if we had to find the 100th term, we could take 3 and add 100 minus 1 6 times. So we would get, or times 6, 3 plus 99 times 6, which would be 594. And then we would just add 3 to get 597. So 597 would be the 100th term. So this is what we consider an explicit formula. And it's important that you realize that the difference between a recursive and an explicit formula. An explicit formula just allows us to write a specific formula for it and not have to continue the pattern out that many times. So this is an explicit formula, because we can find a specific or continued pattern without having to continue it out. So go ahead and take these notes, answer the questions after the video, and be prepared to answer any questions when you come to class, and have a good afternoon.